Regarding the pendulum fire at Farmers City Turbine Lima 3, this breaker, FD005, is out of their ground cabinet, and I've put together a test rig here. Basically, I have a couple of transformers. I'm putting in 240 volt to this transformer, putting out 690. 690 is then feeding this other transformer, and I'm putting out 120 volts. The reason I did this is to create a separately derived system, which would be similar to what the turbine has. This transformer, the 120 volts, then feeds the breaker. We're actually at about 115 volts now. Breaker then feeds this cable. I've got an amp clamp on it. The cable I have is 1.5 millimeter cross section, and I have 93 meters of it, and then comes back in, and I have the two ends actually shorted together, so the conductors are paralleled, effectively making a 3 millimeter cross section for the wire size. The turbine itself actually has a 2.5 millimeter cross section, which is roughly a 14 gauge wire. These parallel together gives me roughly a 13 gauge wire. The transformer I have is rated for 8400 volt amps, and the transformer in the turbine is 7000 volt amps, so it's relatively comparable. So a couple of tests I want to do here on this breaker. The very first one, probably the easiest, I'm just going to turn it on and push the test button. The breaker trips, the little window turns blue, which indicates that the little resistor inside has the ability to trip the breaker. No issue there. The other test I can do is put an actual ground fault on the breaker. So as you can see, I have this yellow wire connected to this plate here, and then that yellow wire, if I were to short out the opposite of what's grounded on the transformer, so in this case, if I short out the ground, the green and black, the breaker trips, and you can see it trips on ground fault. Now if I short out the opposite wire, it's obviously grounded on the transformer side, so nothing happens. So again, I ground out the opposite wire, we get a little spark, breaker trips. That works as expected. Now, another test we can do, I can put a small load on this circuit just to kind of check my amp clamp here. I've got 0.2 amps, which effectively is 0. If I attach this heating circuit, or this heater assembly to the circuit, the heaters are in parallel. There's roughly 32 ohms. Should be about 3.75 amps, and I'm getting about 3.4. Everything's normal as far as that goes. Now, a third test I can do is just a straight phase-to-phase short without a ground being in the circuit. So in this case, if I were to short together phase-to-phase, so this could be the cable shorting against something metal that's not grounded, or the cable shorting against itself. What you'll notice is I'm drawing about 70 amps, and the breaker has not tripped yet. So there, the breaker tripped. Now this particular breaker has a fuse curve called a C fuse curve, which means the instantaneous trip is anywhere between 5 and 10 times the circuit breaker rating. So instantaneous means obviously it would trip right away. I can only get about 70 amps, primarily due to the transformer that's being used and the length of cable. I get such a big voltage drop that the amount of current is limited. So again, 5 to 10 times for instantaneous. So that would be, it's a 25 amp breaker. So anywhere from 125 to 250 amps, it would trip immediately, but we're not seeing that. So again, we're shorted, We have 70 amps. You know, probably takes a good 5 seconds or so for the breaker to trip. You can also see during that test, you can also see my voltage drops down to about 90 volts. Obviously, the more often I do this, the breaker gets hot and it's going to trip sooner. So now if I remove one of these conductors, so again I said that this is a 1.5 millimeter cable or wire. If I remove one of these, instead of being at 3 millimeters, we'll be closer to roughly the 2.5 that's in the tower. And additionally, what you'll see, so if I short these out, instead of drawing 70 amps, we're drawing closer to 50 amps. Obviously the resistance of the wire, since I took that parallel path out, is higher. So drawing a little less current. The voltage drop down to 97. Breaker still trips. So one more last test here is, and that's just a dead short. Now if we had a situation where maybe the cable's not dead shorted and it's just intermittently arcing, what you'll notice is it becomes a bit of an arc welder, and it gets much hotter. And there you can see the cable's actually on fire. So it's and obviously with this intermittent circuit or intermittent shorting, the breaker doesn't trip immediately. So we get some decent sparks, some decent arcs, a little bit of fire there. One more time on the fire show. Oh, my wires are getting worn down to nothing. Actually, they're direct shorted right now, melted together. But again, it's hot enough to start this insulation on fire. You can see the green conductor is now on fire. It's pretty flammable, actually. And it's still energized. So there you have it.